Welcome back to the Math Record. Today I'll be introducing the concept of implicit differentiation and how to do it. So first off, what is implicit differentiation? Well, in all our videos thus far, we have only been finding the derivative of functions in the form y is equal to f of x. So stuff like polynomials, where it's like y is equal to x squared, or like exponentials, where it's like y is equal to 2x, and like trig, where it's like y is equal to cosine of x, or like logs. But basically in all these forms, we have been separating the y's and the x. So in all these cases, the x and y's are separate. So what happens if we have x squared plus y squared is equal to 25? How do we find the derivative of this? Because now they're together. Or if we have something like x plus y is equal to x times y, how do we find the derivative of this? Well, that's when we use implicit differentiation. And this is where we need to learn what the derivative really is. So let's say we have Lipnitz notation for derivative, which is d over dx. What does this really mean? Well, let's use an example to understand this. So if we're taking the derivative of y is equal to x squared, so just a parabola, well, we put both of these to both sides because that's what we're doing the derivative for. So d of dx over y, d of dx of x squared. And then when we were working with apostrophes we had in the form derivative of y is equal to 2x. Comparing them, you see that if we do the derivative in respect to its own variable, we just do the regular derivative. But when we do the derivative in respect to a different variable, we leave behind some kind of weird like derivative. And that's basically what we're going to do in these derivatives. So what we're going to do is if we have a circle, x squared plus y squared is equal to 25, and we do the derivative in respect to x for both of them, we have d of dx of x squared, d of dx of y squared, and d dx of 25. If we do the derivative of this in respect to x, well, x and x, that means we just do the regular derivative, that's 2x. Well, y squared and x, that's different. So the derivative of 2y is 2y, and then we leave behind a derivative, so that's dy over dx. And then derivative of a constant is 0. So simplifying 2y dy over dx equals negative 2x. Divide by 2y, so dy over dx equals negative x over y. So basically, the derivative of this equation of our circle, it depends on its x and y value instead of the x value as we have been doing thus far in our videos. Now let's try our second example to get a little bit more practice. So x plus y equals x times y. Do the derivative of this. So doing the derivative of x, doing the derivative of y, and doing the derivative of xy in respect to x. So whenever we say something in respect to, it means we're doing whatever's in the bottom. So in respect to x, x in respect to x is going to be 1. Y in respect to x, the derivative of y is 1. It's just a singular polynomial. And then if we do, then we leave behind a dy over dx. And then how do we do the derivative of this? Well, we have a function x and a function y, and we're multiplying them, so we use the product rule. So we do d of dx of the first one, multiply by the second one, keep the first one the same, and then do d of dx of the second one. So this is just 1 plus dy over dx, and then d of dx in respect to x, that's just 1. So and then we have our y, so 1 times y is just y, plus, and then we have our x times the derivative of y in respect to x. Well, the derivative of y, which is a polynomial, which is just 1, because the derivative of a linear is just 1. And then multiplied to we leave behind a derivative, so that's dy over dx. So overall, we have 1 plus dy over dx equals y plus x times dy over dx. Now, if we just want dy over dx, we need to combine this one and this one together. So let's move this one to this side and this one to this side. So we get dy over dx minus x times dy over dx is equal to y minus 1. Factoring out your dy over dx, so this becomes our dy over dx. We have 1 minus x is equal to y minus 1, and that just simplifies down to dy over dx is equal to y minus 1 over 1 minus divided by 1 minus x. And that's the derivative of our equation. And one thing I want to note about these derivatives, when you're trying to make sure you're finding an actual derivative, is that the points that you choose has to be true. So even though, let's say we have x is equal to 2 and y is equal to 1, when we plug that in, that's 0 over, actually let's choose a different y value, let's say 3. We have 3 minus 1, that's 2, and then 2 minus 1 minus 2 is negative 1, that is negative 2. This, we have a derivative of negative 2 for 0.23, but if we plug this point into our equation, we have 2 plus 3, x plus y, 2 plus 3, that's 5. And then x times y, that's 2 times 3, that's 6. Well, this is not true. This is not equal to each other. So this point does not lie on this equation. So even though there is a derivative, this doesn't lie there. So you're always going to have to check that the points you choose actually are in the equation for it to have a derivative. Even though it may seem like it has one, you have to make sure that the points are actually there. Well, thanks for watching, and I'll see you at the next math record video.